For this lesson, our focus standard comes from Grade 7, Geometry, Standard B. Solve real-life and mathematical problems involving angle measure. Our topic comes from AGR, Analyzing Geometry Relationships, Name and Classify Angles. Our essential question is, how do you name angles, and what vocabulary do we use to classify them? Please take a moment, pausing the video if you need to copy down the topic and essential question in your header, along with today's date, inside your question column and your note column, and resume the video when you're ready to begin. So let's talk a little bit about angles here. An angle is, here's one example, and there are many different types of angles, but it is defined as the measure of degrees between two intersecting lines or rays. So in this case, we have line segments AB and line segment BC, and they are connected here with this point B to make an angle measurement. So we'd measure this distance between these two line segments. They could be rays or lines in degrees. Now the vertex is point B on this angle because that is the point of intersection. So it's like the corner or the meeting point of those two lines that create the starting spot for this angle. And how do we name angles? Well, there's a few ways to do it, but when we have points like this, and we're showing all the different points that connect to create this angle, then there's some specific things we have to do. So the name of this angle is, this one here, is angle ABC, written here, or angle CBA. Notice that both times B is in the middle, and that is because it is the vertex. When you are naming angles, you use this symbol for angle, and then the vertex point must always be listed in the middle. So it doesn't matter if you go from the top to the middle to the bottom outside, or you start from the bottom outside into the vertex and out, as long as you always list the vertex in the middle. So that's a couple of key things about angles and naming angles. We are going to continue talking about classification, so a lot of vocabulary, or actually all vocabulary in this video lesson. So we basically have two primary ways of classifying angles, and the first is to classify them by their size or by their angle measurement. So here are probably the first 4 types of angles that you have learned since elementary school. Do you recognize any of these or remember what they might be called? Do these names look familiar to you? Well, they are corresponding. So this angle here is called a straight angle. Notice that it is a straight line. So this is again under classification by size. So a straight angle is defined as forming a straight line. So it would be 3 points that create a straight line or a straight angle, and they measure 180 degrees. So we're talking about from this side, from this line segment here, over to the other line segment. That would measure 180 degrees. The second one is probably a very familiar one to you. It's called a right angle, and it's this little box in the corner that we frequently use to signify that it's a right angle. Do you remember how many degrees it measures? That's right. It measures 90 degrees, and it's always formed by 2 perpendicular lines. So one is exactly opposite of the other one. So typically one is running vertical and the other one is running horizontal. But the important thing to note is that this could be found in any kind of rotation, like even like this. And that would be considered a right angle. Well, my points didn't move with it, but you see how the lines move. So that rotation, even if it's like that, that box will signify that this is a right angle measuring 90 degrees. This next angle is what we refer to as an acute angle. And sometimes we use the memory trick of, oh, it's so cute because it's small. It measures less than 90 degrees. And our 4th classification by size is this type of angle here, an obtuse angle. and obtuse angles measure more than 90 degrees. So that is most likely a refresher for you. Let's go ahead and look at some classification by pairs. Here are again, 4 different ways to classify angles by pairs. Let's first look at vertical angles. So to define vertical angles, we look for ones that share a vertex and are directly opposite of each other. So it has to be in the situation like this where we have intersecting lines and they create a variety of angles. And in this situation then, we're looking for places where they share a vertex. So all the angles in this diagram here share the vertex of F. That's the intersection point. And vertical angles are going to be directly opposite of each other. Can you see anywhere where angles are directly opposite? Well, here would be a pair, and that would be measure of angle HFG, and this would be in the directly opposite pair. So always think about it as like the bow tie angles. Those would be vertical angles. So I've listed them here, angle EFI and angle HFG are one pair of vertical angles. Do you see the other pair? Yeah, they'd be these ones right here. So EFH, with sharing that vertex directly opposite of it, would be IFG. And I've listed those here. In this type, and in many types actually, even down here, we can find adjacent angles. Let's talk about those. Adjacent angles share a vertex again and a line and are directly next to each other. We don't know anything about their angle measurements unless we're given other information, but we will refer to them as adjacent angles. So let's look at some examples. So the first one, and I'm using this diagram again, is angle EFI. Angle EFI. So there's one. I'm going to mark it with green. And again, we're talking about adjacent. And that would be adjacent to IFG. IFG. So notice they share the vertex of F and they share this line I. So angle EFI is adjacent to angle IFG. There's a lot more just in this one diagram. Can you spot at least one more? So using the same diagram, one more that I spotted is GFH. GFH, so this angle here, is adjacent to HFE. HFE. So this one here. And again, it's because they share this vertex and they share a line segment. Now these are not the only 2 examples, but they are just 2 examples of adjacent pairs of angles in this diagram. So they're angles that are directly next to each other. This next diagram right here with these angles M and P are talking about complementary angles. So again, as pairs, complementary angles are angles that combine to equal 90 degrees. So angle MNP is a 90-degree angle because it has this box, right, showing that it's a right angle. But notice that there's actually 2 angles inside of it. So angle MNO, this part right here, is complementary to angle ONP. Because together, when you put them together and they are adjacent, because they share a vertex and this line here, are angles that add up to 90 degrees, which make them complementary. And our last vocabulary word is supplementary angles. Let's talk about that. Here's a diagram right here. So supplementary angles are angle pairs that combine to equal 180 degrees. So notice here's that straight angle that we talked about above. It's QRS, makes a straight line, meaning it's a straight angle, and measures 180 degrees. And in this case, we've made 2 smaller angles that are supplementary. because together angle QRT combines with angle TRS, and would add up for a total of 180 degrees. We would see that from here to here, adding this little measurement and this measurement, they would equal 180 degrees. That makes them supplementary. So there's two different ways to classify angle pairs and angle relationships, and that is by pairs and by size. And it's important that we know how to describe the parts and name angles. That's going to conclude our video for today, and thanks for tuning in.